pursued additional roles, various responsibilities at the institute departmental level. Like he has worked as assistant registrar establishment. He has also worked as coordinator in alumni affairs. He is the coordinator in COSIS, social awareness and outreach activities. He is co-PI in Unnat Bharat Abhiyan. He has also worked as departmental training and placement officer. He has also worked as departmental DDU QIP coordinator. He the As far as his academic excellence, he has published five journals and he has attended seven conferences. He has also organized 10 FDP faculty development programs, and he has also delivered four expert lectures. And as for the BTech project, he has supervised and completed 15 BTech projects. Various students have completed 15 BTech projects under his supervision. So in today's lecture, he will be going to deliver on the topic public health from water quality and perspective. And this water quality, it is very essential to our day-to-day life, because we are suffering from arsenic pollution and lot of pollution. And since water is the basic essential need of our day-to-day life, so I am welcoming and Professor Avaneesh Yadav to deliver the lecture on this topic. Avnish sir. Avnish sir, am I
Yes,
audible?
yes, you are audible. Am I audible?
Yes, yes.
Is my
You can
screen
proceed.
is my screen visible?
Yes, yes, yes. You can
Oh,
make it full screen.
okay. First of all, I would like to extend my sincere thanks to Dr. Jiten Pratap Singh, co-coordinator of this FDP, for inviting me as an expert to deliver the lecture on public health from water quality perspective. And I welcome all the participants of this FDP, and I hope this session will be very interactive and fruitful in knowledge enhancement. So let me first is it visible in full screen or it is not? Jiten sir?
It is not visible in full screen, sir.
Okay, 1 minute.
Press F5, it will. Or you can continue, sir.
Okay, I'm not getting the option for full screen. It has been minimized perhaps.
No problem, sir. You can continue, sir.
I can zoom in for better visibility. So, as Dr. Jitendra has already given the brief description of the topic, that public health from water quality perspective, uh, as we all know that water is very essential for human being as well as for animals, and we consume it in ample amount on daily basis. So its availability in sufficient quantity as well as sufficient quality or desired quality is of very much importance. So we will be discussing today about the various water quality parameters and their significance, their sources, and especially from the health point of view, and wherever there is significance from industrial point of view, from our environmental point of view, from aquatic life point of view, I have also added some note about that. So let us scroll over about the contents of the PPT. First, there is introduction, and then collection, transportation, and storage of water sample for testing. There are various water quality parameters. They are divided in three subcategories: physical parameters, chemical parameters, and biological parameters. And then there are some references of this slides from wherever there is some necessary references are there. So, to begin with, as we know that there are several waterborne diseases such as diarrhea, cholera, typhoid, fluorosis, dental fluorosis, skeletal fluorosis. These are related to directly consuming poor quality of water or water deficient from the required minerals or the chemicals which are desired to our body. So, water is directly linked to our health. Therefore, environmental engineering is also called as public health engineering in some states. I belong to UP. There is environmental engineering term, and in Madhya Pradesh and perhaps in Bihar, there is public health engineering department. So they are synonymous to each other because environmental engineering is directly related to public health. It affects the public health. The connection between consumption of water or treatment of wastewater to the public health is necessary to be discussed. So, as per data, there are about 2 billion people globally who consume contaminated water. Means there are total 8 billion people, 800 crore people in the world, and about 25% they are not getting pure water for consumption. Means they are indirectly suffering from waterborne diseases, and it is aiding to their financial burden in treatment of these diseases, and the sufferings are separate. So, a safe water supply is a fundamental for sustainable public health. In our constitution, there is also a provision of right to life in Article 21. In Article 21 and right to life, 1 minute. This is a right to life article I'm underlining. And if we have to live the dignified life, we have to consume clean water to be healthy in proper conditions so that we can function efficiently. So there is a provision of indirect provision for clean water. It is covered under Right to Life Act, and it is a fundamental right to get clean water as a citizen of India. There are also provision of duties of citizens as well as state to protect our environment. Article 48A and 51AG. These two articles cover the duties of states and citizens. As we have given rights, so there are linked some duties, such as we have to avoid the contamination of water. We have to preserve water. We don't have to waste water too much, consume as less as possible, and don't pollute the water bodies by dumping the solid waste or disposing the untreated effluents. These are the duties of citizens as well as the state. State means the state government or central government. They have to ensure that the rivers or open surface bodies or groundwater remains safe for consumption or the intended use. So our duties are also very clearly written in Article 48A and 51G. In Sustainable Development Goal 6, there is provision of clean water and sanitation. As we know that United Nations have devised several sustainable development goals, and one of them is clean water and sanitation. That's why they are also giving quite emphasis for clean water so that the consumer could remain healthy. So now we are talking about the water pollution. Pollution means usually people think that if any undesirable substance is present in water, then water is polluted. But it is not completely true, because if any undesirable substance is available beyond a certain limit, then it is called as water is polluted. For example, if chromium is present in concentration more than 0.05 mg per liter in water, then water is called not fit for drinking. in terms of chromium concentration. But if it is available in 0.01 mg per liter, then there are no adverse health effects in consuming this water. So chromium is undesirable substance. We try that its concentration should be zero, but it has been observed that if its concentration is up to 0.05 mg per liter, then it is safe for human consumption, and water is not called polluted until this condition is met. So pollution is misinterpreted sometimes. So I wanted to clear this point. Now there are some case examples or case studies for poor water quality in India. There are some regions where some concentrations, some pollutants are available in excessive concentrations, such as fluoride is found in excess concentration in more than 20 states in India. So I have mentioned the effect of high fluoride concentration in further slides. There are more than 20 states where who are affected through excessive fluoride concentration. Arsenic is found in excess in West Bengal and Bihar. So this entire region is prone to arsenic due to their soil structure and rock containing arsenic. The groundwater is severely polluted. As far as in my knowledge is concerned, in Balia district of Uttar Pradesh, Jal Jeevan Mission scheme is being implemented in Balia. It is neighboring to Bihar. So there is also arsenic contamination in groundwater. So Jal Jeevan Mission, they are trying to dig the bore wells to tap the groundwater in most of the districts or most of the locations. But the groundwater is severely polluted in Balia by arsenic contamination. So they are treating surface water of lakes and nearby rivers for supplying the drinking water, because treatment of water laden with arsenic in bulk amounts is little costly. So it is better to treat surface water and supply to the residents of these districts or these areas which are contaminated through arsenic. In Yamuna and Ganga river basin, these are also very polluted because these two are major rivers of North India, and many famous cities are located. Densely populated cities are located. So population is also huge, as well as industries are also there to cater the needs of this population. So their discharge, domestic discharge and industrial discharge, both are going to be mixed in the river water, and it is unsafe for human consumption. As this was not the case about 100 or 200 years ago. People used to directly drink the water from rivers, but even if you have gone through the newspapers during Mahakumbh, the Ganga water was not safe for even bathing. It was not for bathing quality. In terms of fecal coliform contamination, it was more than 25,000 per 100 ml at several locations in Prayagraj. So rivers are also being affected. And why this river pollution is affecting us? First of all, there are several creatures, aquatic animals, microorganisms, algae, which are found in these rivers. They balance the ecosystem. Fishes are the sources of livelihood. And if these fishes are consuming some contaminated water, especially metallic contamination, and we are consuming these fish, so the food chain is getting disturbed, and those contaminants are entering the food chain and in our body also. The river water is used for supplying to irrigation, for irrigation purposes. So those contaminants are also going to crop, and we are eating them indirectly. So entire food chain is getting polluted. So this is the significance of river water pollution, and we have to minimize it. I have read a report or seen some news that there is a huge chromium contamination in Ganga near Kanpur due to tannery effluent. As we know that Kanpur is famous for its leather throughout the world. Kanpur is famous for leather production, and in leather is produced in tannery industry. For leather, since leather is very soft material, so to make it hard, in form of earth and belt, it needs to get tanned. And for tanning, chromium related substances are used. So when the leather is getting washed and tanned by the chromium laden substances, and the effluent water contains huge concentration of chromium. These, as per CPCB guidelines, these chromium laden water should be treated and brought back to the 0.05 mg per liter concentration. But due to poor implementation of these rules, chromium as high as 40 mg per liter has been reported in Ganga Basin near Kanpur, which is about 800 times more than prescribed limits. 800 times more than prescribed limit. And even in watermelons, cucumbers, which are grown in the banks of these rivers, the chromium is getting transferred to watermelons, and we are eating it happily, and it is getting to our food chain. So our immunity is getting weak, and we are being severely ill. So these are some scenarios, some case scenarios which I have gone through in newspaper or research papers recently. One case study I want to tell that we are involved as a civil engineer, as a professor of civil engineering, we are involved in consultancy and testing. So I happened to visit our project in Lakhimpur Kheri district, where Dudhwa National Park is situated, Lakhimpur Kheri district, where they had constructed a soak pit of septic tank, where the effluent of septic tank is sent and it is soaked by the underneath soil and the side walls of the soil. And there is also a mandatory provision of rainwater harvesting in every government building. These two systems were created, and since the engineers did not care for the connection of these two systems, they connected both rainwater harvesting tank and soak pits together. What happens in rainwater harvesting? There is a deep bore well, and there is gravel and sand layer. So rainwater gets filtered through these layers of sand and gravel, and it is discharged into the groundwater through the perforated pipes. If the soak pit is connected to the same rainwater harvesting tank, then the effluent of the toilet is also getting pumped into the ground. So due to pumping of this effluent, and the water aquifer underneath will get contaminated or deeply polluted through fecal contamination or the contamination of the toilet. So entire area, the extent of this aquifer, which is usually about a few kilometers large, people may get ill and they don't know the reason, because at some place the soak pit and rainwater harvesting is connected, and the entire waste material from the toilet is getting dumped into groundwater. Such things have to be taken care, because the contractors and the masons, they are not so well knowledgeable persons. So they had committed this mistake, and since the project was not started, we had gone there after before handing over. So it was rectified. They made their separate connections. Now there are strategies for ensuring safe water. Am I audible, and is it getting clear? Can anyone tell from the audience?
Yes, you are audible, sir.
Okay, thank you. So what are the strategies for ensuring safe water? First of all, if we want to ensure that water is safe or not, we have to sample it and monitor its quality from different sources from where we are taking the water. So sampling and monitoring, which we will discuss in further slides, is one of the aspects of strategies. Next is community awareness. If people are aware that how the water should be disposed of and what parameters are essential for our body, then they will be aware, and water they may consume safer water, as compared to if they are nor not knowledgeable. So government is also implementing many programs such as Jal Jeevan Mission, which I already told. Namami Gange program, everyone might have been aware that Ganga cleaning mission, it is related to cleaning of water Ganga. Amrut 2.0 and Smart Cities mission, it is focused on constructing sewage treatment plants and reusing the wastewater for various purposes, for agriculture, for horticulture, and even for drinking water purposes if required. So government programs are also there to ensure that communities as well as industries are getting the water of desired quality. Now, since there are several regulations such as Water Water Act 1974, Environmental Pollution Act 1986, but these are not being effectively implemented. So mere drafting the regulation is not sufficient, but their enforcement through government bodies such as Central Pollution Control Board, State Pollution Control Board, urban local bodies such as Nagar Palika, Nagar Nigam, they have to monitor the quality of effluents from various industries situated under their jurisdiction. Now, we move to water quality assessment. To ensure that water is safe for human consumption, as well as for domestic and industrial uses, uh, as per the standards set by various bodies such as CPCB, Central Pollution Control Board, Bureau of Indian Standards, or WHO, it is essential to measure the various water quality parameters. For example, if we get ill, we get our blood test done to any pathology. We don't directly consume medicines in general. We get our blood test done and know which parameters are not meeting the standard criteria. So we identify the problem and then we take medicines. So same thing is for water. Whatever water we are consuming in any form, for laundry purposes, for industrial purposes, for drinking purposes, then we have to identify the sources. We have to get it tested in laboratories, especially NABL accredited laboratories, and we have to find the root causes of any diseases which are being common in that particular area, so that we can identify which parameter is not meeting the desired limit. For example, people usually put RO units in their houses for water, for drinking water purposes. Reverse osmosis plants or small kits are there. So people usually get it installed in their houses, and they think that the water is being consumed by them is safe. But that may not harm you. The water treated with RO and UV filtration, they may not harm you, but these treatment units make the essential elements such as calcium, magnesium, fluoride, fluoride ion, divide of these minerals. They filter out these essential minerals which are required for our body, and our teeth and bones will become weak if we are not getting sufficient amount of calcium. If we are not getting sufficient amount of magnesium, our heart will not function properly. If we are not getting sufficient amount of fluoride, our teeth and bone will decay. So in less awareness or not awareness, there is people are not aware, so they install RO units and filter out all the even essential minerals too and consume this water. For this, there is desirable treatment. After that, RO filtration, there should be a unit for mineral addition. So these minerals should be added and then consumed, so that we don't have to take medical supplements for supplementing these uh, elements or minerals. So as per NGT guidelines, few years ago, I had read an article that National Green Tribunal, which is a semi-judicial body for environment-related issues, or its jurisdiction is only for environment-related issues, and retired justice of Supreme Court and High Court are the members of this tribunal. So it has given its decision that if in any area there is less than 500 mg per liter of TDS, total dissolved solids, then RO unit should not be installed. So means if up to 500 mg per liter of TDS, water is safe for consumption. But some activists and the mainly RO manufacturing companies, they went to Supreme Court and quashed this decision of NGT. But in real scenario also, if TDS is about 300, 400 or 500, it is safe for consumption, provided that you have to characterize the TDS. TDS means total dissolved solid. Which kinds of solids are present in water? If that is arsenic or chromium or copper or lead or mercury, then even 50 mg per liter may be dangerous. But if it is iron, magnesium, calcium, sodium, then it may be beneficial. So only TDS value is not sufficient for putting RO units at our houses. We have to characterize the water, what constituents are there which are causing this much of TDS. And if these are beneficial, we may continue without RO units. And if they are not beneficial, they are harmful, we have to install RO units, and then supplementary mineral units also should also be added, so that we get desired quality of water, and our body could function well without taking any supplements. So next is collection and transportation and storage of water samples. So we have to characterize or test the water samples in laboratory. For that, we have to collect the sample. So for groundwater, we may collect in from the hand pumps or tube wells we are taking, and for rivers, we have to go to river or surface bodies or lakes with sterilized bottles and clean bottles. It may be plastic and glass. There is a separate sample collection manual. If anyone is interested, I will share it. That is huge protocol. But in general, I have written that water bottles should be clean and they should be sterilized. If there is a concept of disinfection and sterilization. Usually in water treatment, we prefer disinfection. It means that we have to kill only pathogenic organisms. Pathogenic means it is related to pathology, means disease causing microorganisms. So by adding chlorine or ozone, we usually kill the pathogenic microorganisms which are causing disease. But for the sample collecting bottles should be sterilized. Sterilized means pathogens and non-pathogens, any kind of life should be absent from our bottles. Means any kind of bacteria or virus, they should be killed before the water samples are brought for collection. Otherwise, they may contaminate or pollute the water, and it may give us misinformation. That is why there is written avoid contamination during sample collection. Transport the collected samples to the lab as soon as possible. Since various parameters are there which may get changed with temperature, with time. There is bacteriological activities always happening in the water. So we have to test the water sample as soon as possible. For this, if our sample collection site is far away, it is taking few hours to transport the sample to laboratory, then we may bring chill pack containers, which you might have seen this box for polio vaccination people. These persons carry these box and polio vaccines inside it, and they give the doses to the children. So, there are few packets which we have to keep in the deep freezer. Ice will be formed, and we have to carry this container. It is mostly heat insulated to the site, collect the sample, put the bottles inside this chill pack container, and bring to the laboratory so that most of the parameters remain stable. For pH and temperature, these two parameters we should test immediately, and we don't have put the bottle in for temperature in chill pack containers. Bring the water directly, and it is desirable that bring a thermometer. It is easily portable device to the sample collection site and take the on-site temperature for real measurement. Don't depend on the laboratory measurement, because temperature will vary in transportation. For dissolved oxygen measurement, perform DO fixation on the site. DO fixation means from the surface water sources such as rivers and lakes or ponds, if you are carrying sample, dissolved oxygen had in the river is different. And if we bring that water to laboratory after 6 hours and we start testing, the dissolved oxygen amount may decrease, because the bacteria and organic matter present in water, bacteria will continue consuming this organic matter, and some amount of oxygen is also consumed in the process. When we will measure in the lab, we will report lesser amount of DO as compared to the actual river dissolved oxygen. So we bring these two chemicals, manganese sulfate and alkali iodide azide solution, to our collection site and bring a 300 ml BOD bottle. We will collect sample for DO for measurement of DO in BOD bottles, which has a standard volume of 300 ml. In BOD bottle, we shall fill the sample in such a way that during filling there is no oxygen bubble is inserted. So extreme care is taken that water is inserted in the bottle through its neck, and no air bubbles should be formed, otherwise dissolved oxygen value will increase. After adding the water to the neck, we put the cork at the top and then add 2 ml of MnSO4 and 2 ml of alkali iodide azide solution at the bottom of the bottle through pipette at the bottom of the bottle. These two chemicals are heavy, they settle down at the bottom, and 4 ml of water sample is expelled out. Then we put the cork and shake the sample bottle properly, so that entire dissolved oxygen is precipitated in form of MnO2. So conversion of free oxygen or dissolved oxygen to MnO2 through these chemicals is called dissolved oxygen fixation. So now this MnO2 cannot be consumed by the bacteria present in this water sample during transportation. So we are free to test it after a day or 2 days later. The total amount of oxygen is now fixed in form of MnO2, and bacteria is unable to break this bond of manganese and oxygen to consume this oxygen. So this is the safer method, and we should take care for it during dissolved oxygen sample collection. For all other most of the parameters test, we should use refrigeration at 4 degrees Celsius. It is the standard temperature. We should bring the sample in chill pack and then transfer it to the freezer at 4 degrees centigrade, and we may test it for a day after or the same day at later time. So what water quality parameters matter most to us? I shall briefly go each of them, and whenever there is a requirement of some justification, I shall give proper justification. But there is constraint of time that all the parameters cannot be discussed in detail. So the parameters are divided in 3 categories: physical parameters, chemical parameters, and biological or bacteriological parameters. So physical parameters means which we can feel through our senses. Physics, as you know, it is also a total feeling based thing. So temperature we can feel by our hand or by taste. Color we can see by our eyes. Odor we can smell by our nose. Taste we can taste with our tongue. Turbidity means suspended particles are there in water. There are suspended particles of salts or any organic or inorganic matter. We can see by our naked eyes, and there are many solids, dissolved solids or suspended solids or volatile solids. They can also be seen. So these are physical parameters. They can easily be detected through our eyes or touch or smell or taste, but there are some rational methods also devised for their measurement. There are chemical parameters we shall discuss in next slide. And there are two important bacteriological parameters: biochemical oxygen demand and most probable number, MPN test. So first parameter, physical parameter, is temperature. So why water gets temperature? From its, mainly from its surrounding, from nature, either from sunlight, if through wind. If wind is chill, then water temperature will be lower. Soil type, so if it is underground water, then it will take the temperature of the surrounding soil. If the soil is sandy, it gets very cool, very hot in less time, and very cool in even lesser time. So the water in contact with some sandy soil, its temperature may slightly change, but some other parameters are there through which water temperature may vary. For example, industrial sources, uh, where water is used as coolant in industries, the water gets warm. So in thermal power plants, water is used to run the turbines. It is converted to vapor, and vapor is put through turbines, on turbine blades, and blades are rotated, and electricity is generated. But that heat is condensed, and if it is discharged in the rivers or surface water bodies, then the water temperature will change. Similar case is for cold storages. Its water also is at higher temperatures, so it should not be directly discharged into the surface water bodies. Otherwise, many aquatic animals may get killed. So, what is the significance why we require to measure the temperature? First of all, temperature affects the taste. For example, this is the summer or rainy season, and we try to prefer the water from refrigerator, some colder water for taste, for better taste. And in vice versa, in winters, we prefer a little lukewarm water for consumption. So it is desirable that water should be about 25 to 20, 30 degrees degree temperature optimum, and depending upon the climate and weather, it may vary. But as a civil engineer, we may not supply the water at desired temperature in masses, because there are million of liters for requirement for a city, and we cannot increase the temperature or decrease the temperature of entire million liters of water. So people do it individually at their homes. Next, the temperature governs the various chemical reactions. For example, solubility of gases decreases with increase in temperature, whereas solubility of solids increases. So if temperature is high, gases will not be easily dissolved in water. They will get evaporated. So if temperature is high, dissolved oxygen in surface water bodies will decrease. For example, at noon or in summers, the dissolved oxygen in rivers is decreased, and in winters it may slightly increase due to temperature effect. So in summers, there may be some aquatic animals which may suffocate to death due to absence of oxygen, and leading to ecological imbalances. So there are many other reactions which are temperature dependent. There are endothermic reactions, exothermic reactions, as we have already learned in class 12th chemistry. So temperature plays very important role in treatment of water. Next is temperature governs the biological activities. For example, uh, fruits, vegetables we buy from the market and put in refrigerator. What happens at in refrigerator? There is temperature close to zero, even less than zero. So biological activity get reduced significantly, and our fruits or vegetables, they don't get rotten easily. But at high temperatures, usually 25 to 35 degrees centigrade, the bacterial activity is significant, and in summers, these fruits are usually get rotten very in very quick time as compared to winter. So we need refrigeration. So temperature plays a very significant role. If temperature is suitable for the growth of bacteria and microorganisms, then they will grow, and they may decompose our organic waste, or even some, if algae and other creatures are growing, they will create a layer, a green layer like this. if there are sufficient amount of nutrients from agricultural runoff, such as nitrogen, phosphorus, sulfur, and temperature is also little higher side of the river, and these agricultural effluents are getting discharged through rainwater runoff to the water bodies, then such kind of layer of algae is deposited. It is called algal bloom, and the phenomena is called eutrophication of lakes. So sunlight will not get to the bottom, and many creatures and small plants and microorganisms may die. So our ecological balance of the river will get disturbed. So temperature plays very crucial role in these parameters, in governing of these reactions and parameters. Second parameter is color. So though color is not very objectionable thing if we know the sources. For example, if we give you to drink shikanji, means sharbat, it is colorful, and you will happily consume it because you know the ingredients of this sharbat, that it is sugar. But if I give you similar pale water which contains iron from a hand pump, and you don't know the source why it is pale or why it is brownish, then you will reject or refuse to drink such water. So color is aesthetically unacceptable, means दिखने में ही ये अच्छा नहीं है, you will visually reject it upon first sight. So there are many sources of color such as nature, soil, and minerals are there, such as iron gives pale color, copper gives blue color, plant leaves they decay and they give a brownish color or a greenish color. In some industrial wastes are there, if they are mixed to water bodies or groundwater, they give the color used in that industry. For example, in textile industry, various colors are various dyes are used. They have different colors for dyeing the cloths. So if those dyes are disposed, then water get the color of those dyes. Paper and pulp industry also uses bleaching to remove the color, and if water is discharged without treating, then it will give the color to water bodies, and we will deny to use, though it may affect or not affect our health directly. But if we don't know the sources of color, it is objectionable and unacceptable. So also colorful water is not desirable for laundry, for washing clothes, for washing utensils, for dyeing industry, textile industry, etc. Color can be removed through filtration, and that color is apparent color means आभासी color होता है इसका हिंदी में, मतलब means ये हमें आभास हो रहा है, but if we give the time to settle the suspended particles, usually it is caused due to suspended or colloidal particles, and if we give time to the sample, the color may disappear. For example, if we take water and we mix some soil in it and leave the at the instance of mixing, we will see that the water is turbid and it has color, matmela color ho jayega, and after some time we will see that all the soil will settle at the bottom, except if it is not colloidal in nature, and the supernatant liquid will be fresh. So its color will disappear. It is called as apparent color or false color or temporary color. It is due to inorganic nature, inorganic origin such as sand, clay, silt, etc. But true color cannot be removed from the by simply settling. So we need to give a special treatment, some chemical treatment, adsorption to remove the color depending upon the origin and type of the color. So it is not removable. It is measured using Nessler tubes. There is platinum cobalt scale is used. I am not focusing on the methods of measurement more because there are several laboratory manuals. American Public Health Association AFA manual standard methods is there, and there are IS code 3025 different part for detailed discussion on the procedure. But I am focusing on significance and adverse effect on our health or industries, whatever the case may be. So Nestler tubes are simpler tubes of various colors, as you might have seen some creams, such as I had seen the ad of a Fair and Lovely cream. Fair and Lovely है इसका नाम, where there was a strip printed, various, so at the top there were darker strips, at the bottom there were lighter strips, and at the bottom there was quite fair strip. So in the advertisement, they say that uh, first, when you purchase this cream, match your skin color, and after using 1 month or so, whatever they say, and you will see the significant improvement to the lower side of color strips. Similar type of color comparison is done through Nestler tubes, and it is compared through the 1 mg per liter of platinum cobalt is dissolved in water and what color it gives. So it is compared with respect to that. Next is order. Order, it comes from the foreign materials which are present in water. So this may be organic or inorganic matter, chemicals, dissolved gases, etc. And their significance is that if water has some odd order, objectionable order, then people avoid drinking and they will reject the water to drink. So they may contain some harmful substances. If consumed, they may cause some diseases. It is measured using osmoscope. It is an instrument, and where dilution is used. For example, we take 100 ml of our sample whose order to be determined, and we add equal volume of, and if it has some smell, and we first add equal volume of water, 100 ml more, total volume becomes 200 ml, and we smell that the order has been disappeared or not. If it has not been disappeared, then we further add 100 ml of water, and we define a threshold order number. It is the total volume upon sample volume. For example, in this case, if 300 ml water was used and smell just disappeared, then its threshold order number will be 300 upon 100 is equal to 3. So maximum permissible limit for drinking purposes is 1 to 3. If it is 1, it is already orderless, and it is 3, then threshold order number is 300 upon 100. So it is calculated like that. Next is turbidity. Turbidity is the property of water due to which it causes interference to the passage of light through water. So it is mainly due to presence of finely divided suspended particles in water. They may be organic or inorganic in nature. If there are silt, sand, clay in water, and we pass light through it, then light get reflected or scattered or refracted. There may be various phenomena of lights. They may be get absorbed, and some light is transmitted. So if we pass this light, then some light is scattered or reflected, refracted, absorbed, and the transmitted light is received here. So what is the significance of turbidity? Why we study in environmental engineering? For drinking water purposes, if turbidity is visible clearly, then people may reject to drink the water if sources are not known. But if it is glucon-D, you might have seen that if we dissolve the glucon-D, there are some suspended or colloidal particles are there. It is turbid, but we happily drink it. But if we don't know the ingredients, we will reject. So for drinking water purposes, it is aesthetically unacceptable for drinking because it may contain pollutants. For river water sources, if water is turbid or any surface water, if there is river or lake, water is turbid, then sunlight will not pass through up to the bottom. And at the bottom of these surface bodies, there are small tiny plants which produce oxygen upon photosynthesis. So photosynthesis is only possible in presence of sunlight. But if water is turbid, sunlight is unable to reach the bottom of the river, and photosynthesis will be affected. Then you know that in photosynthesis, oxygen is released. If oxygen is not released, then all the aquatic animal will suffer from deficiency of oxygen, and those who are vulnerable, they may die. So this is the significance for surface water point of view. Also, turbid water creates problem in chlorination, and it also provides sites for microorganisms growth. For example, if there are some suspended particles, the bacteria will stick on these particles and they will give birth to their children or further microorganisms, and they will create sites of diseases. If they are pathogens, then if we consume such water, then we may get ill to consume this water. So these provide additional sites, suspended sites or colonies or for home to bacteria, and this is not desirable in water. Measurement, its measurement is done through turbidity meter or nephelometer. Turbidity meters, they work on principle of reflection, transmission, and nephelometers work on principle of reflection at 90 degrees. You may read in detail through various laboratory manuals and textbooks. This is the image of low turbid water to high turbidity water. The turbid water looks like the water given in these glasses. Leftmost water is almost fresh. This has no turbidity, and the rightmost bottle is most turbid. This is the procedure for determination. There is a turbidity meter, which may be simply turbidity meter or nephelometer, where we have to first calibrate the equipment. Now, most of the persons, perhaps everyone might have been aware from the calibration word. So can anyone tell me what is calibration, or in chats or through by unmuting yourself? Calibrating equipment, why it is required and what does it mean? From any participant? Am I audible? Yes,
Yes, you are audible.
setting a standard for testing. Yes, these electronic equipment mainly when they turned off and when turned on again, their setting may slightly get disturbed. So they may not give you the actual correct reading. So we have to tell them that what is the correct reading first from the standard solutions, and then we measure our given sample. So first we calibrate it with the 400 NTU nephelometric turbidity unit. It is the measure of turbidity. 400 NTU solution. We make is from a pharmazine solution, or there are various reagents of whatever turbidity meter you are using. It is already available with the turbidity meter, or we may prepare it fresh in the laboratory. So we first prepare 400 NTU solution as per the given guideline. What reagents have to be dissolved in which amount of distilled water. It is already mentioned in the laboratory manuals. So after preparing these samples, we first put this 400 NTU sample in this turbidity meter, and turbidity meter will give you reading, for example, 420. So we are confident that this 400 value is much accurate than the what turbidity meter is telling. So there is a knob for calibration. We will rotate the knob and set the value to 400. We are telling our turbidity meter that the value which you are showing 420, it is not 420, it is 400, because we are confident of our standard solution. Then we shall press OK. Then we take the fresh distilled water. Distilled water has zero turbidity, zero NTU, and we shall insert it in the turbidity meter. It will give some value. It may give zero value, or it may give 1 or 2 value. Then we will rotate the knob and set the value to 0. And now it has been calibrated. Then we shall put our sample, and whatever reading is shown at the display of this nephelometer will be the turbidity of our sample. So it is a small procedure. I got some flow chart, so I included it in the slide. Then there are solids. Solids may be of different kinds: total dissolved solid, total suspended solid, and total volatile solids and fixed solids. Usually dissolved solids are those solids which cannot be filtered. Non-filterable solids are also, these are called non-filterable solids. And dissolve, I have mistakenly written dissolved solid both times. It is suspended solid. It is suspended solid, not dissolved solid. Suspended solids. So dissolved solids are permanent. They don't settle with time. Suspended solids will settle with time. We measure them using Wattman 42 micron filter paper. And if these are present, they are objectionable and they cause interference to the passage of light. And as I have already told in the turbidity, the total solids are equal to total dissolved solids plus total suspended solids and volatile solids plus fixed solids. Volatile solids are organic in nature. Fixed solids are inorganic nature. For example, kitchen waste or leaves or paper, these are volatile. If we heat our sample in muffle furnace in at 550 degrees Celsius, then all the volatile material will get vaporized and only fixed solids or inorganic solids will remain at the bottom, which are usually soil or sand or clay. These origin or eggshells are there. They don't get vaporized even at this much temperature, and this temperature is created in muffle furnace, and the sample is put in crucible, silica crucible. I have written it. Silica crucible is used for sustaining this high temperature. Porcelain dish is used for putting sample in simple hot air oven for measuring TDS and TSS. And desiccator is used for cooling the our filter paper in controlled environment. There is desiccator is a closed lid glass type of a pot in which there is silica gel which is water absorbent in nature. It is placed and a perforated plate is placed. There is a lid. Then the filter paper on which we have performed the filtration for calculating total dissolved solids and total suspended solids. We put it in hot air oven at 105 degree, and then we have to measure its weight. Before measuring, what students or people usually don't take care that they direct put it on weighing machine. So weighing machine directly give the weight, but in hot condition the weight is incorrect. So first we have to put in desiccator. In desiccator, what does in desiccator there is no moisture inside it. So when your filter paper is getting cooled, there is no add-on of moisture, and after cooling, take the paper out and immediately put on the weighing machine to take the correct weight. Otherwise, weight is not correct. So, and in some cases, if some student keep this desiccator open, then all the moisture from the air will be absorbed by this silica gel, and it needs to be recharged. It has some capacity to absorb moisture. It cannot absorb infinite moisture. So after it has exhausted, put it in hot air oven. Its moisture will be removed and it will be put in the put again in the desiccator. Now we are moving to pH because time is getting lapsed very fast. So I am moving a little quicker. pH, we all know it is minus log H ion concentration, and it measures how much acidic or basic the water is. The pH range for drinking water is 6.5 to 8.5. We are not going to drink the water which is more acidic, because in our intestine there is already acidic atmosphere to digest the food we eat. If we further drink the water having acidic pH, acidity will be caused, and we have to take the medication, or we have to drink the ENO for neutralizing this excess acid. So we usually avoid drinking water in acidic range. For water used in preparing and curing concrete, the pH should be less than should not be less than 6. Means acidic range is not permissible, more acidic range. and it may go to any basic range, because in cement hydration, calcium hydroxide is formed, and if it will react the acids, then it will leave spores, and it will make the concrete prone to the acid attack or chemical attack, or weathering through acid rains, and the reinforcement may get corroded. High pH leads to corrosion of metallic pipes for if we are supplying. So if corrosion is happening, we have to replace the pipe before its end of life, and it will increase the economic burden or financial cost will increase. pH is also required to be maintained for various water treatment processes such as chlorination, coagulation. These processes are performed at definite pH values. So we need to perform pH test of water. So there is infographics of pH, the PPT I will share with Dr. Jitendra sir. So he may share with you in the group. And this is the process of measurement, and we have to calibrate the pH meter by using 4 pH, 7 pH, and 9.2 pH buffer solution. Here, buffer solutions are used because buffer has the property that a small amount of addition of acid or base, its pH don't change, and it can be used for longer time. So there are 3-point calibration facilities in the pH meter. We calibrate 1 pH in acidic range, 1 in neutral, and 1 basic range, and then measure our required value. The next parameter is acidity. People usually get confused from pH and acidity and alkalinity. pH tells the value of how much acidic or basic the water is, but acidity tells the value that how much base is required to neutralize the water. So, its significance is that while treating various waters and wastewater, a specific pH should be maintained. For example, if your water has pH 6, so you cannot supply for drinking. So you have to add the base to the water so that its pH could be brought back to 6.5 and above. So we have to perform the neutralization through acidity test. So acidity has two major causes: CO2 acidity. In atmosphere, there is a small amount of CO2 gas which may get absorbed in water, and it forms carbonic acid H2CO3, which is a weak acid, and the pH is not lowered much. It is about 5 to 6 pH. H2CO3 is weak acid, so it does not lower pH much below, but it remains close to 6 or 5.5. But if mineral acids such as H2SO4, HNO3, HCl, these are strong acids, these are present, then pH is lowered significantly, and we have to treat the water with more bases, and more base is consumed, or your economy will be affected. It is measured in terms of CaCO3 equivalent because it is the most common salt found in groundwaters. So we measure hardness, alkalinity, acidity with reference to this. Now, one precaution has to be taken care of, that sodium hydroxide or potassium hydroxide, these are used for titration to determine the acidity. These are formed. These are available easily in form of pellets. Pellets means in form of small tablets. We have to close the lid of container very tightly, otherwise they absorb the moisture from the air very quickly, and they become liquid. And if they have absorbed the moisture and become liquid, if we take their weight, the weight will include the NaOH amount and the amount of the moisture too. So our reading will be incorrect. So we have to take care that in laboratory, NaOH, KOH, their containers should be closed very tightly so that their weight measurements are correct. And these phenolphthalein and methyl orange indicators are used in determination. I'm not going in deep. Similarly, alkalinity is there. It is the capacity of water to neutralize the strong acid. It is exactly opposite to the acidity. So it is caused due to carbonates, bicarbonates, and hydroxide ion present in. And H2SO4 is used as titrant in alkalinity because strong acid को neutralize करने की capacity भी हम assess कर रहे हैं, तो हमको strong acid H2SO4 use करते हैं. Yeah, here one point has to be noted that for diluting H2SO4 to 0.02 N concentration, it is very dilute concentration. What generally we do, it is H2SO4. If we have to dilute, we add distilled water to it. But H2SO4 has very high affinity to water. if we are adding water to it, to concentrated H2SO4, H2SO4 has high affection to distilled water. It may jump to catch the distilled water. And if you are not wearing gloves or proper safety equipment, then your hand may burn down. So diluting H2SO4, we pour the H2SO4 in distilled water, so that if now H2SO4 is attracted towards to distilled water, it will move downwards and your hands will remain safe. So it needs to be clearly emphasized during experiment to the students that diluting H2SO4 needs reverse process as compared to the normal reagents. So this needs to be taken care of. There is a concept of hardness. It mainly refers to the presence of multivalent cations, single, double valency or triple valency cations such as calcium, magnesium, strontium, and aluminium 3+. They cause hardness. So hard water tastes bitter. Some its taste is थोड़ा कड़वा type का लगेगा, and it is not pleasant to the tongue. So from the taste of point of view, it is not acceptable. Also, more soap is consumed while washing the cloths and washing the utensils. The soap gets replaces these ions get replaces the components of the soap, and more soap is required until unless they are neutralized. Also, there is one industrial point application that in thermal power plants, what happens? Electricity is produced by boiling the water in large boilers, size of a room or even more than that. So coal is burnt, heat is produced to the bottom of the boiler. These water get boiled and produces steam. These steams are thrown to the blades of turbines and they rotate and magnetic field changes and electricity is generated. But if your water is hard and it has temporary hardness, so temporary hardness is called by is due to presence of carbonate and bicarbonates. They get deposited at the bottom upon boiling. So if you are supplying water to industry which is hard and contains temporary hardness, after some time there will be a formation of scale. Papdi ek ban jayegi at the bottom of this boiler. Now to heat the same amount of water, you require more heat because this layer is formed of calcium carbonate और चूना की लेयर जैसे बन जाएगी, नीचे एक डिपॉजिट एक पपड़ी बन जाएगी. देन ये हीटिंग में अफेक्ट करेगा. मोर कोल विल बी कंज्यूम्ड, इलेक्ट्रिसिटी की कॉस्ट बढ़ेगी और वो कॉस्ट कंज्यूमर्स पे थोपी जाएगी, तो हमारे लिए इलेक्ट्रिसिटी महंगी होगी. तो एज अ सिविल इंजीनियर, इफ वी हैव to supply water to some industries which use boiling, then we have to take care of this temporary hardness factor. Also, there is a factor of incrustation in pipes. In drinking water supplies, these if water is hard, the calcium carbonate etc. get precipitated in the pipes, and effective diameter it will get precipitated at the surfaces, and effective diameter of pipe will be reduced, and we have to replace the pipes very soon, and the desired amount of water cannot be supplied. Then there is chloride parameter. It is due to presence of urine. We consume the salt NaCl, and the chlorine is filtered through our kidneys as such, and it is discharged through urine. If soil contains some elements of chloride, seawater intrusion. In coastal areas, India has very vast coastline, and in coastal areas, usually seawater penetrates through the groundwater, and chlorine is found, and it impacts the taste. We will feel the salty taste of water. इसमें खारा पानी लगेगा, तो हमको ये टेस्ट नहीं चाहिए. कई सारी इंडस्ट्रीज हैं which discharge the chlorine related effluents in the water, and chlorine gets mixed in it. Also, as a civil engineer, chloride is harmful for concrete also. So as per IS 456, there is a provision that for construction of RCC in seawater, we have to use minimum M20 grade of concrete, M30 grade of concrete for RCC construction in seawater. For example, Bandra Worli Sea Link, which is perhaps now called as ATAL Setu in Mumbai, it is constructed in Arabian Sea. So minimum grade would have been used equal to M30, or even it might be greater than that. Or for normal concreting, it is minimum grade M20 for normal RCC work. So chloride causes corrosion to the reinforcement if it gets included in the concrete. It is determined using Mohor's method or azerometric method in laboratory, and a pH of 7 to 8 needs to be maintained. I have make it bold because in pH we had said that a significance of pH, that in many reactions, chemical reactions take place at suitable pH, that desirable pH. So pH measurement is essential for performing these reactions. Next is residual chlorine. Its source is that we add intentionally to the drinking water supply, because if we add chlorine for killing pathogens, and if we kill all pathogens exactly and all chlorine is consumed, but during transportation, if there is some leakage at joint and some wastewater or some soil is inserted, then it may bring back to some bacteria in the pipeline after treatment. So it will be supplied to the households. So some extra chlorine equal to 0.2 to 0.3 mg per liter should be retained at the last step. At the last consumer, at least this amount should be obtained during measurement, so that we can ensure that all the chlorine, all the drinking water supply was safe from bacterial or microorganism contamination. So it is very essential parameter. We keep it in excess. If at the last step it is 0, then it might be possible that all the bacteria or pathogens might have not been killed, and we have to increase the chlorine dose at our treatment plant. It is measured using starch iodide test. And one thing has to be noted, that while using starch, it needs slight heat. It needs to be heated slightly before using. Otherwise, it don't develop the blue color with the iodine. So practically, we have to take care that it has to be heated slightly. And this test is performed at pH 3.5 to 4.2. Again, it is required to measure the pH, and significance of pH is validated here again. Dissolve oxygen. It is the oxygen which is present in form of free O2. Free O2, not in form of H2O. There is oxygen which is chemically bonded with hydrogen. Bacteria cannot break this strong hydrogen bond and consume this oxygen from water. So the water which is in form of the oxygen which is form of O2, it is consumed by the living organisms and by the bacteria, which for decomposition of organic matter. Usually dissolved oxygen should be 4 to 8 mg per liter. For drinking water supplies. High DO may cause corrosion of metallic pipes, so it is kept in this range. Surface water bodies should have minimum 4 mg per liter for sufficient concentration of aquatic animals. Hello, is someone talking something? Jiten sir?
Avani sir, we have only 15 minutes left.
Okay, in 5 to 7 minutes, I'm concluding.
Can you wrap it up easily?
Okay. Okay. Then there is fluoride. Its range is very critical. It is essential that water should contain minimum 1 mg per liter of fluoride concentration and maximum 1.5 mg per liter of fluoride concentration. If it is more than 1 mg per liter, then dental caries and tooth decay will happen, as shown in the left figure. Then tooth will degrade and their color will change. If it is more than 1.5 mg per liter, their color will change. Discoloration will happen because fluoride is a strong decolorization agent. Skeletal fluorosis is very commonly found in the areas where groundwater contains the high concentration of fluoride. The bones of people get deformed, as this is X-ray image of such deformation of bones. If such symptoms are being seen, then water should be tested for fluoride first. Then I have included determination of metals through spectrophotometer. So I will briefly summarize through a graph. I have not included any content for it. Spectrophotometer is a device, is equipment for measurement of various concentrations, in which we fix a wavelength of some desired value for different parameters, and we make standard solutions of different concentrations, and we measure their reflectance, how much uh, light is being reflected or transmitted to the from the sample. So we plot a graph from concentration versus uh, absorbance, how much is reflected or how much is being absorbed. It may be calculated, and this graph has some equation: y is equal to mx or y is equal to mx plus c. For unknown sample collections, we put our value, our sample in the spectrophotometer. Is it gives some absorbance, and corresponding to at that absorbance we may determine the concentration. So it is the basic principle of determining the metals. Many metals are determined through it, such as iron, manganese, chromium, etc. These are determined through a spectrophotometer. There is chemical oxygen demand. This parameter determines the total biodegradable plus non-biodegradable organic matter in non-biodegradable organic matter in wastewater samples, and it is very crucial parameter for complete treatment of for complete removal of organic matters. Then there is biochemical oxygen demand. I had left few more slides blank, but the time is not permitting. It is for biodegradable organic matter determination, and important for measuring the pollution, organic pollution load of the waste stream. It is a parameter for wastewater. And one last parameter is most probable number, which indicates the fecal contamination of water. Our intestine contains crores of E. coli bacteria, coliform group of bacteria, which is discharged through the toilet or latrine of daily. So to confirm the presence of feces, और जिसको हिंदी में हम लोग मल बोलते हैं, अगर उसकी प्रेजेंस आपको पानी में देखना है तो आप ई कोलाई का टेस्ट करें, so that if E. coli is present, then fecal matter is present, and the water should be straightforward discarded, and it should not be used for drinking, otherwise people may get ill. So I had thought if time will would have permit, then I had described this all in detail, but only this content could have been covered. Thank you. Now questions. If there is any question from the respected participants, they may raise it.
If any question is
Hello.
there, audience. If any question is there, yes, please ask the question from Avneesh sir. Is it audible, sir?
Yes, it is audible, and
sir,
perhaps
we are Buxar city. In this Buxar city, the water
yes.
contamination is pure arsenic.
Okay.
So should we rely on RO water or UV water or mixture
Is
of
RO
and UV? What we have to done?
Sir, actually, RO is better for removing. It is efficient in removing arsenic. UV is for pathogens. It kills the bacteria or viruses which are harmful. So, if water is not prone to certain bacterial contamination, then UV may be skipped. But RO is necessary. But RO will filter arsenic as well as the essential minerals or compounds which are required on daily basis to our body, such as calcium, iron, magnesium, and fluoride. So we have to ensure that after the filtration is completed, there is an add-on unit which supplies these essential things to our water, so that we don't get deficient in these minerals. Otherwise, we have to get our annual blood checkup and measure what deficiencies we have. Usually, calcium deficiency is very common in India. We might have to take supplements for a month or two. I belong to a family of doctors. My brother and father both are doctors. So we have annual practice of preventive health checkup. And usually, even after taking supplements, there is a little deficiency of calcium. So and they tell us that it is inherent in our continent, on subcontinent in an entire country. So there is genetic deformation. So we have to take supplements of these things. And the mineral water which we purchase, Aquafina, Bisleri from the market, that is also treated with RO and UV, and then some mineral is added. So that is called mineral water. So those mineral, if you read the packaging of those bottles, they clearly show what minerals have been added after treatment. So that is called wholesome water. It is complete. I will like to add to the participants that there are mainly three type of waters which are used in environmental engineering. One is palatable water, which is visibly very clear, that is aesthetically acceptable, but it may be contaminated through bacteria or any metallic pollutants. So, but visibly it is very clean. So, if someone drinks, it may harm or may not harm. Then there is potable water. Potable water means water which is safe for drinking, but it may contain some taste and odor. For example, chlorine treated water हम लोग पीते हैं. We क्लोरीन ट्रीटेड वाटर में थोड़ी स्मेल आती है, but that smell, despite of that smell, we consume that water because that is safe for our human consumption. But that does not have some added minerals. For to make potable water wholesome water, we have to add the essential minerals which our body require on daily basis. These elements are required in certain amount to our body in daily basis. We have to take those through food. These are found in some food such as eggs and milk. They are they contain very ample amount of calcium. So we may supplement from food, and if that is not also sufficient, then we may take further supplements or add-on of these minerals. So for arsenic, sir, go for RO. Otherwise, there are certain other techniques, but for ready-made units, for home treatments, RO is better.
Thank you, sir. Thank you, sir. So
okay,
it's 7:26 because next session is from 7:30.
Okay, sir.
So we both, myself and Jitendra sir, both thanks to you that your presentation is really very informative, very nice, sir. You have explained each and everything. There's still many questions in our mind, but because of the time constraint, maybe in future through mail or what phone number we will
Yes, sir.
contact
Sure,
you.
sir.
Okay,
Yes, sir.
sir.
Okay, sir.
Thank you, sir. Thank you. So should I close this meeting, sir?
Okay, sir. I would also like to thank you both for organizing such an informative and very useful FDP. And we would like to collaborate in future ventures also. Thank you, sir.
Okay, sir.
Okay.